Okay, so the second part of today's lesson is looking at where lines cross. So the obvious thing to do first is where does a straight line cross the x and y axis? And this usually comes down to something quite simple. And if we think about all the coordinates of any point on the x-axis, we might have 2, 0, we might have -5, 0, we might have 6, 0, we might have a coordinate of 101, 0. But on the x-axis, y is always 0, and that is the key. So if we're finding where a line crosses the x-axis, we set y to be 0. Equally, think about coordinates on the y-axis. You've got 0, 7. You've got 0, -2. You've got 0, -101. So in this case, on the y-axis, it's the x part of the coordinate that is always 0. And we use this fact to work out where straight lines meet the x and the y axis. Now in last lesson we learnt that there's two new forms of writing the equation of the line, this standard form and this gradient point form. But we can use what we've just said to find where they cross the x and the y axis. So on the x axis, y is 0. So I can say 5x plus 2 lots of 0 minus 10 equals 0. Well, 2 lots of nothing is still nothing. So I'm left with the equation 5x minus 10 equals 0. So 5x equals 10. So we get x equals 2. Let's do the y-axis. So on the y-axis, where the line crosses the y-axis, x is 0. So I've got 5 lots of 0, 5 lots of x, plus 2y minus 10 is 0. 5 lots of 0 is 0, so 2y minus 10 is 0, so 2y equals 10, so y equals 5. So they cross at, I'm going to draw one axis in the middle and we'll put both lines on. Crosses the y-axis at 5 and it crosses the x-axis at 2. So the line on the left-hand side is going to look like that. Right, let's do the right-hand side equation. So again, on the x-axis, y is 0. So 0 plus 2 is equal to a half of x plus 3. Right, you could expand this out first. So you've got a half of x plus 3 over 2. You could at this point times by 2 to get rid of the denominators. So 4 is equal to x plus 3. So that means x is equal to 1. Again, on the y-axis, we set x to be 0. So in this time, this one's a bit easier. Y plus 2 is a half of 0 plus 3. Well, 0 plus 3 is 3. A half of that is 3 over 2. So I've got y plus 2 equals 3 over 2. So y equals minus a half. So I'll draw this in green on the same axes. So it crosses at x equals 1 and it crosses at y equals minus a half. So this line looks like that. Okay. You have a go, work out where each of these lines cross the x and the y axis and then do yourself a sketch. Press pause and I'll show you the solutions when you press play again. Okay, so here are the solutions. So I'm not going to go through these. You can press pause and have a look. So there's question 1, 2. Here's 3, 4. And 5 and 6. Right, so now we've got to look at where two different lines intersect. Again, it's a nice idea to try and sketch this because it sort of like gives you an idea of what's going on. So, quick sketch of this one. So I've got y equals 3x minus 4. I know it crosses the y-axis at minus 4. I know it's got a gradient of 3, so I'm not going to work it out. I'm just going to draw a steepish line. So that's my y equals 3x minus 4. Next, I'm going to draw the line y equals 8 minus x. I know it crosses at 8. I know it's got a gradient of -1. So that's probably going to look something like this. Right, the key to this is this point here where they cross. And at this point, I'm going to call it xy. But the x is the same x in both equations. And the y is the same y in both equations. So this and this y are both equal. And because the two y's are equal to each other, what I can actually write is this is equal to this because they're both at the same point. So I can write 3x minus 4 is equal to 8 minus x. And now I've just got one equation, one unknown. I can solve this. Add x to both sides. So I've got 4x minus 4 equals 8. Add 4 to both sides. I've got 4x equals 12. So my x equals 3. So I know this is at the point x is 3. And then I can work out what my y value is, what this y value here is, by substituting it into either equation. It really doesn't matter. So I'll prove that by doing both. So let's do y equals 3x minus 4. So y is 3 lots of 3, take away 4. Well, 3 lots of 3 is 9, take away 4 is 5. And let's do it with the other equation. 8 take away x. So I've got y is 8 take away 3. So y is 5. So again, it didn't matter which one I use. So general rule of thumb is use the one that's going to be easiest. And your point of intersection is the point 3, 5. Okay. Now these were both in the y equals mx plus c form. But obviously you can get situations where you might be in different forms. So we might have one in the y equals mx plus c form over here. And we've got another one that's in its gradient point form. So with this one, it's a bit tricky to make the y's equal to each other. But the same statement is true. This y here is exactly the same as this y over here at the point at which the two lines cross. And that means I can actually substitute this into here because my y equals 4x minus 5. So I can use 4x minus 5 in this position over here. And so what I can then do is I can write 4x minus 5 plus 2, because I'm just replacing this y with 4x minus 5, is equal to 3 brackets x plus 1. And this sort of solving equations like this is called a process of elimination. You're eliminating the y by substitution, okay? So we're going to tidy this up. So 4x, well, minus 5 add 2 is going to be minus 3. And now I'm going to expand this bracket on this side as well. So I'm going to have 3x plus 3. We need to get the x's on one side. So I'm going to take away the 3x's from this side and the other side. So I end up with x minus 3 equals plus 3. Add 3 to both sides. X equals 6. Okay. Worked out the x. So now I need to work out what the y is. I'm going to use the easiest equation, which I think is the one on the right hand side. So I'm going to say y is 4x minus 5. So y is 4 lots of 6, take away 5. 4 lots of 6 is 24, so y is 19. So the point of intersection is 619. Okay, we might have two equations that are in standard form. So we can actually solve these in a totally different way, because if we look at these two equations, we sort of think about simultaneous equations. And actually, if I wrote my first equation as 2x minus 3y equals minus 2 by taking away the 2, and if I look at the second equation and add the 6, I'd have x plus 2y equals 6. And at the point at which the two lines intersect, the x and the y's are the same, so it's just solving a pair of simultaneous equations. So I'm going to multiply every term of the second equation by 2. So I've got 2x plus 4y equals 12. And then I'm going to take one equation away from the other. So just to be clear, I'm going to write this over here the other way round, because I'm going to say I want the top equation take away the bottom equation. So I've got 4y take away minus 3y. If you take away a negative, that becomes 7y. Equally, I've got 12. Actually, I get my highlighter here. I've got 12 take away minus 2. And again, taking away that negative is the same as adding. So I've got 12 add 2 is 14. So y equals 7. Once you've found one of them, substitute it in. X plus 2y equals 6. I'm going to use that equation. So I'm going to have x plus 2 lots of 7 equals 6. X plus 14 equals 6. So x is going to be minus 8. So the point of intersection is minus 8, 7. And the last one, we've got a bit of y equals mx plus c form and a bit of standard form. Okay, again, various ways you can do it, but personally, I would substitute that into there for my y. So I would then write 4x minus, now this is where you have to be careful because you're taking away all of this. So it's minus a half x minus 1 minus 6 equals 0. Now 4x take away a half x is 3.5x, I hear you all say, but we would write that as 7 over 2x. Minus 1 minus 6 is minus 7 equals 0. So 7 over 2x is 7. Add 7 to both sides. Multiply both sides by 2, so you get 7x equals 14. And then divide by 7, and you get x equals 2. Okay? You can use that in either equation. I'd probably go for the right hand side because it looks a bit easier. So I'd probably use y equals a half x plus 1. So y is a half of 2 plus 1. Half of 2 is 1, so we get y equals 2. So these two lines intersect at the point 2, 2. Okay? Right, last little bit then. I've got 4 questions for you to have a go at. Find the point where the two lines intersect. Again, there's various different methods that you can use. Have a go and I will show you the solutions in a minute. So press pause and have a go. Okay, so here are the solutions. So first one, just equate the y's because they're both in the form y equals mx plus c. Numbers aren't particularly nice, but this can happen at A level. The second one, because you've got a y equals mx plus c and then a standard form, I would use the substitution. I would substitute that 4 minus x into where the y goes. So that means I'm substituting this 4 minus x into here. Okay. Right, number 3. Now these are both in standard form, so I'd probably solve simultaneously. So I'd end up with the y equals 7, substitute it in, and then you get x equals minus 5. And the last one is probably the most awkward, okay, because it's a bit difficult. You don't really know what to do. You haven't got simultaneous equations here, and you can't just use substitution. But you've got to rearrange one of them so you can substitute. So in that case, I would take this equation here and rearrange it. I would add the y to both sides. And then I would use the substitution, and hopefully you had the point of intersection as 13 over 2 minus 1/2. Okay everyone, that's it for the videos. Try and have a go at the worksheet that's now on Edmodo.